We have changed the presentation. This should be the last one, but we have changed it. But I really appreciate all the speaker of today, because most of you have speak about basic on different water processes for decontamination and disinfection. So in my case, just I'm going to explain you very brief an overview of why microorganisms can be activated by all of these different processes in the water. So this is just a brief overview of what we are going to see in the presentation. Just a brief introduction about what are microorganisms, then some view of the main water processes that we use for inactivate microorganisms. Then we are going to more focus on the inactivation mechanisms that, from my point of view, is the main message I want to give all of you. And finally, just a brief conclusion. So microorganisms are unicellular alive forms that can found everywhere, spread around the whole world. You can find in all type of environments. They are unicellular or individual cell forms that can live alone or also in forming colonies. There are different groups of microorganisms, and one of the specific description of these cells are you can only observe using a microscope. They are not easily observed. And there are different groups where microorganisms are divided. These include bacteria, fungi, archaeas, and protozoa, also viruses. Some scientists included them like alive forms, others not. Then we will see more specifically about that. And here you have just a single scheme of what is the main components of a bacterium, which is the main group probably you know from microorganisms. It consists on a cell wall that protect the inside of the microorganisms. Oh, sorry. This a little bit extreme. They have also some pilus and flagellum in some cases for the movement of the microorganisms in the water. And also inside the microorganisms we have the genetic material, which is the core of the life. Another type of structures needed to keep the function of the cells. And in that case, there is some examples of different shapes that microorganisms have. In this slide, it's just to show you that the microorganisms, or when we speak about bacteria, we will see this scale go from 1.9 nanometers to 1 millimeter. Here we have bacteria. In that case, we have humanids, frogids, and in this extreme we have an atom, just to see the scale of the microorganisms. So when we speak about microorganisms, as I told you before, we have 4 main groups in which they are divided because they have different structures and different cycles of life. So the most popular is bacteria. They are prokaryotic cells, which mean prokaryotic, and eukaryotic is one of the main division of the cells in the life. And this is because prokaryotic, the DNA, the genetic material, is separate from the rest of the protoplasm and the configuration of internal structure of the cell by a nucleus. So it's separate. And in that case, we say that these cells are prokaryote in comparison with eukaryotic cells. That is the normal cells. We are formed with eukaryotic cells. That means they contain a nucleus separating the genetic material from the rest of the organelles inside the cells. This concept is quite important in the taxonomic classification of all the cells in this world. So we have bacteria. Here you have just to compare the diameter also. Fungi, everybody knows also fungi, they are eukaryotic cells. We have also protozoa, which are other type of eukaryotic microorganisms, and also viruses, that is the most simple structure, and some scientific, they don't accept these viruses like a life force because they have not complete the full cycle of life. They need to parasite other cells to complete the cycle. So they don't say or accept this is real cells, but it's containing in water, and this is quite important in generation infections. So all these 4 groups of microorganisms, we have benefits microorganisms that make activities that are okay for the life, for the environment, but then there are other groups that can generate disease in humans, or even in plants, or even in animals. And in that moment is when we say that microorganisms are pathogens, because they can generate a real disease in other organisms. So when we speak about water disinfection, we focus on those type of microorganisms because this is our objective, to inactivate all of these microorganisms that are harmful for humans. And in this table, we have a brief summary. There are many others also, but the more common microorganisms that we can detect in wastewater secondary effluents. Okay, we have the group of bacteria. We have examples of bacteria like Bacillus, Clostridium, Escherichia coli, which is the main indicator of fecal contamination in water, and they are used in all the regulation of and policy and guidelines of drinking water and wastewater reuse as indicator of the fecal contamination. Other microorganisms like Salmonella, Shigella, Yersinia enterocolitica, parasite protozoa like Cryptosporidium parvum and Giardia lamblia, we are also commonly included in all this regulation, like parameters to be followed in the water and establish the limit for which the water can be used for one use or other use. Also some helminths, and of course virus like enterovirus, rotavirus, or virus Norwalk. All these water pathogens has the characteristics of generate disease that normally affect the stomach, the intestine, generating the famous diarrhea, the famous vomiting, poisoning, etc. Some pinks, etc. Then recently there is another concern in the reuse and in the treatment of urban wastewater that has been appeared recently because researchers and scientists has started to observe that bacteria, normally focus in bacteria, they are resistant to many different types of antibiotics. And this is a real problem for medicine and for treating infection, because if you are infected with a bacteria that is resistant to antibiotic, how you are going to treat the infection? And from last years, maybe 5, 6 years or more or less, we have started to see that in the water, in the wastewater, we have a lot of bacteria that can be resist the presence of very low concentration of different antibiotics. That's the concern that recently in 2017, the World Health Organization established and presented a table with several bacteria and with the corresponding antibiotic resistance like critical height and medium level, because they can resist most and the most advanced type of antibiotics. So this is a real concern when we speak about water disinfection, because the resistance coming inside the bacteria, but because this is transferred between cells to cells artificially by the use of some genetic molecule that is called plasmid, that it can be transferred individually, independently between cell to cell. So this can be spread in the medium very, very easily. And if one bacteria is resistant, the one that is not resistant will die, and the resistant will spread very, very quick. So this is a real problem, and also actually the inactivation of the genes, not only the bacteria, but also what happens with that specific molecules, plasmid, and resistant genes are inactivated from the water is very, very important. So when we speak about a water treatment, we say, okay, what is disinfection? Disinfection is the inactivation or inhibition or killing of the water pathogens, that microorganisms that can generate an infection. But it's different from the term of sterilization. Sometimes people can think that this is the same, and sterilization is not the same. Sterilization is the process that kills everything in the water, and if you have completely stored, there is not recontaminated. And disinfection is just to eliminate all of these elements that are harmful for humans, okay? And the water treatment is the process that makes this water acceptable for any use. This use can be drink, this use can be reused for agriculture, this use can be for many other activities. And water treatment includes the inactivation of the waterborne, but also the removal of hazardous chemical compounds, because when you are applying some photocatalytic treatment, you can do both things simultaneously. So there is different disinfection techniques. There is the techniques that only remove the bacteria or the microorganisms from the water. That is physical treatment, including the flocculation, sedimentation, and also the typical filtration. But with these processes, you are not killing bacteria. You just are removing from the water. And then we have the techniques that really inactivate microorganisms. The most popular are chlorination, the ozonation, the UV disinfection, the solar water disinfection. This is quite interesting because Carmen has said before, has referred about the use of solar light for inactivate bacteria. And then we have also, of course, the advanced oxidation processes, like the typical photocatalysis, the combination of hydrogen peroxide with the UV, or some with hydrogen peroxide, the photophantom, etc. So the main difference, as I say, is okay. Both are widely used. Probably physical removal is even widely used. Both. When we speak about cost, this can be taken with care, because depending on many parameters and many different things. Physical removal do not destroy the microorganisms, and the other processes inactivate, but also sometimes can generate flavor to the water, depending on the processes and what is the chemical composition of this water. And also can be even expensive, and in some cases also can generate hazardous compounds as a consequence of the application of this process. Here in this table, just I would like to show you very brief the most common drinking water treatment that can be used at household, because there is many countries where drinking water is treated locally or in no centralized system like happening in developing countries. So we have the method of course, the chlorination. We have also filtration, the flocculation, the boiling, the UV disinfection, and the solar disinfection, which is probably the most low-cost system for treat water with the objective of making potable for drinking, using in developing countries. And this consists on fill bottles of PET bottles, like you want for drinking with the contaminated water. You put it under the sunlight, and the effect of the solar light in a synergy with the temperature, the mild temperature that it can achieve the water, destroying the bacteria and make the water acceptable for use. And we know that this reduces the impact of disease in the people, and this is recognized by the World Health Organization like a household water treatment intervention procedure at household. Okay, most of the same processes can be also achieved in centralized system with distribution capabilities for making drinking water and other type of water of many people in cities and in developed countries, like chlorination, filtration, activated carbon, ozone, UVC, and also the advanced oxidation processes, like the one here, especially this the combination of hydrogen peroxide with UV or ozone with UV, etc. But then, okay, before I also introduced you some parameters that can be considered when we want to investigate and we want to know the overall efficiency of water processes. There are different parameters that affect finally this efficiency. One of them has been already also explained before, like water pH, the water composition, because they have organic matter, inorganic compounds that can affect the processes. But when we speak about advanced oxidation processes, especially driven by solar energy, there are other parameters that are quite important for water disinfection, which is the solar radiation intensity, because they affect directly the capability of the bacteria to survive. The temperature, because the thermal effect on microorganisms is also quite important, and it's interesting to know how the temperature that it can reach under natural sunlight, it can affect the inactivation of each microorganisms, and this range can be also vary depending on the type of microorganisms. It can normally generate a synergy in solar processes when we increase between 30, 35, or 40 degrees. The water turbidity, of course, when we are speaking about solar photochemical and solar photocatalytic processes, is important because turbidity removes strongly the efficiency, because it reduces the pathway of photons in any solar reactors or when we are doing the reaction. And then we have, of course, two parameters that are quite also very important. The first one is the type of microorganisms. The resistance of the different groups we have seen before is different. So the response and the time and the efficiency of the processes will be also depending on what type of target microorganisms we are evaluating. And of course, then the type of treatment, if are more oxidative, less oxidative, etc. The range of resistance to being activated go from bacteria, then viruses, and then spores, and also cysts of protozoa. To understand better the targets and what are the main points in microorganisms that are affected when we apply a water treatment, we need to go individually from outside or from inside, the cells to outside. There are different key targets in a microorganism. First, the genetic material, then the proteins and other compounds, the enzymes, which are proteins that are enzymes are proteins that catalyze some biological reaction inside the bacteria, are quite important to keep the normal functioning of cells, and then the external cell wall, which is protecting the microorganisms from outside. Other important things when we apply a water treatment is the microorganisms have the capability to adapt and resist and repair some damage during the processes. So the microorganisms go from the state of alive, then they are accumulated damage inside, but if the process is cut in a step where the microorganism is not completely killed, it can be recovered sometimes. So this is also important to consider when we apply our water processes. And if the process is strong enough, the microorganisms finally will die, and there is not possible to regrowth. So now we are going to see briefly these key targets of the microorganisms that explain why these cells are inactivated. The DNA, the DNA is the genetic molecule that contains all cells and is the basis of the life. This is a helicoidal molecules, complex, which have different bases called adenine and thymine, which are complementary. This is the structure, the main structure, and the DNA, which contains all the information for generate all the activities that need the cells to stay alive. It can be generate mutation, that means alteration in the combination and also in the structure of this molecule. So when this happens by photoabsorption or even by reactive oxygen species attack, in this molecule start appearing some mutation in the molecule, and finally this cannot be translate all this information. So at the end, the cells decide that it cannot be continuously working normally, and they die. Then enzymes. The enzymes are, as I told you before, they are proteins that act as catalysts in many different types of internal reactions. They, like typical catalysts, increase the reaction of chemicals, and many inside the cells they are generating different and a lot of type of reaction. So very basic. This is the structure of an enzyme. This is a three-dimensional composition of a big macromolecule that is three-dimensional structure and interact with their specific substrate. When this happens, the enzyme accelerate a change in the substrate and then generate a product. That is the baseline of actuation of an enzyme. And these enzymes can be affected by different things. So when this three-dimensional structure is modified, the activity of the enzyme is stopped and it cannot work. Among the factors that can be affected, we have drugs, we have temperature, we have also pH, but one very important is also the photoabsorption under natural sunlight. So all these factors affect the activity of the enzymes, so they are not work. So many activities are stopped. When we think about enzymes, they are very, very important, especially those that act related with the biological control of reactive oxygen species inside the microorganisms. And in this scenario, the enzymes called superoxide dismutase and catalase are very important because they keep control the superoxide and the hydrogen peroxide that is generated inside the microorganisms. Inside the microorganisms by the aerobic metabolism. So when these two enzymes are inactivated, of course, what is happening? The increase of superoxide radicals and also the increase of hydrogen peroxide with internally reacting with iron that is contained inside microorganisms, generating the well-known Fenton reaction. Okay? So this increases the radicals, the hydroxyl radicals inside the microorganisms. So this generates a lot of damage inside the microorganisms that will finally, this accumulation will finally permit the inactivation of microorganisms. And then when we speak, the last key target of microorganisms is the cell wall. Okay, when the cell wall is affected by hydroxyl radicals or other type of radicals, depending on the type of the treatment, will be affected physically. This generates malfunctioning because this through cell wall is in the interaction with the external cell. So finally, when this is completely disrupt the homeostasis, the internal homeostasis of microorganisms cannot be kept, and of course it's dead. So the cell wall is very important to determine the resistance we saw before, because the composition of the cell wall is completely different from one group of microorganisms to other. Like I have not too much time, I will be quick. We have two types. When we speak about bacteria, we have two main groups, which is called gram-negative and gram-positive bacteria. Gram-negative bacteria normally are less resistant than the gram-positive bacteria because they contain this layer, which is called peptidoglycan. It's made of some proteins that the thicker is higher. Under some circumstances, they permit to be more resistant to some processes. This is regarding the bacteria. In the cases of viruses, they have this part, this green part is called the capside. It's also made of proteins, a thicker layer of proteins that is protecting the genetic material. This is just two different types of viruses. This is human viruses and this is a bacteriophage. And then we speak about the spores, which are the more resistant. It's because they have many different layers of proteins that protect these microorganisms, this type of microorganisms from the external factors. So this is the typical photocatalytic processes we have studied at the Plataforma Solar de Almería. Of course, we work with SAL. I'm going to very quick. Yes, very quick. Yes. Okay, this is, I'm going to explain you what is happening in the microorganisms under this type of solar processes. This is the baseline, what happens in a bacteria, in a typical bacteria when we're under natural sunlight. Okay, when the photons reach the microorganisms, the reactive oxygen species increase because the enzymes that we speak before are inactivated, and this generate that all these reactive oxygen species affect the DNA, affect other part of the microorganisms, and this generate the inactivation of bacteria. Other processes that is very efficient for the inactivation of bacteria when using solar light is the use of very low concentration of hydrogen peroxide, because this is not because it's happening photolysis of the hydrogen peroxide. If not, in that case, it's because the hydrogen peroxide added to the water can go inside the cells, react with the iron that is naturally occurring inside the microorganisms, and generate by internal Fenton reaction hydroxyl radicals that affect internally the microorganisms. So we are complicated the scenario, and when we add to the water the hydrogen peroxide with iron to have the photophantom processes, what is happening is also the iron can go inside the bacteria, react with the hydrogen peroxide that is accumulating, and generate also all these kind of radicals. But when we have a photophantom, some molecules can be absorbed on the cell wall of the microorganisms, generating also hydroxyl radicals on the cell wall. And of course, the typical reaction that is happening externally by the reaction between hydrogen peroxide and the iron. And in the case of the use of semiconductors, normally all these reactions happen, but when the particle is absorbed on the surface of the cell wall, which is also favor because the cell wall have normally a negative charge externally, and depending on the pH, the semiconductor has also have different external change, and this can be favor the absorption between the catalyst and the microorganisms. So just to end. Sorry. The water is a vehicle of transmission of microorganisms, so they can be inactivated from the water. There are different water disinfection processes. Most of them work for that purposes. And it is very important to understand the type of microbial target and the inactivation way of each processes to understand what is happening with the microorganisms in their overall efficiency when we apply a water process. So that's it. Thank you.